In this video, we'll be reviewing the process of how to take the derivative of an arc trig function. Again, that's just simply saying how to take the derivative of an inverse trig function. So in this video right here, we're looking at arc cotangent. Now the first thing I'm going to do is I'm going to first start by setting arc cotangent equal to y. This will allow me to first manipulate this function so that I can take the cotangent of both sides of this function. In doing so, I have the cotangent of y is then equal to the cotangent of all of this, but remember, if we talk about the arc cotangent function is nothing more than the inverse cotangent. So the cotangent of arc cotangent will simply cancel each other out, giving me just x back. So now I have the cotangent of y equals to x. This right here I can actually take the antiderivative of because I know what the derivative of cotangent of anything is. So I'm going to start with both sides, taking the derivative first of cotangent of y equals to the derivative of x. Now the derivative of x is simply 1. And the derivative of cotangent is, again, recall, negative cosecant squared. So when I take the derivative of cotangent of anything, I get negative cosecant squared of that thing. I'm going to take that and I'm going to multiply it by the derivative of the inside, where the inside is y. So I get dy dx. So now I have this, and I can go ahead and solve for dy dx. If I solve for dy dx, I obtain that this is 1 divided by a negative cosecant squared of y. But recall, if I can solve this for y, I'm going to go ahead and back substitute what it really is. So in this case, I have to move back up to this piece right here, where I know cotangent of y is equal to x. Another way I can see this is cotangent of y equals to x over 1, which means that, and I'm going to rewrite this as tangent of y equals to 1 over x. The reason why I'm going to change it from cotangent to tangent, and again, since cotangent is just the reciprocal of tangent, I can just go ahead and flip those fractions. The reason why I'm changing it is because this is a lot easier for me to remember how to build a triangle from. Now remember, any value that's inside of a regular trig function, not a arc trig function, but a regular trig function, is nothing more than an angle. So I have an angle here that's y, I have my right angle here in a triangle, and tangent is supposed to be opposite over adjacent. So the piece that we're missing is this thing right here, which again, remember, you can go ahead and do 1 squared plus x squared equals to c squared, where this thing right here is c. So if I were to solve, I get the square root of 1 plus x squared. So this provides me with the piece that I'm going to need to solve for cosecant squared. Now, we can manipulate this function right here so that I can see it as, remember, cosecant is 1 over sine. So that means that this is the same thing as a negative sine squared of y. Identifying this allows me to say, well, if I'm looking for sine, I'm simply going to go ahead and redesign what sine is, sine being the opposite over the hypotenuse. So now I'm going to end up with a negative 1 divided by the square root of 1 plus x squared. But the piece that we have to be careful about here is that this is squared. And it's not the negative that's squared, it's the sine function that's squared. Which means that I'm going to go ahead and square this thing right here. If I remember how I'm allowed to deal with powers and over multiplication or division, I can distribute this power to the 1, I can distribute this power to the square root. This will provide me with negative 1 squared divided by the square root of 1 plus x squared in parentheses squared. But a square root of something squared is simply that thing. So I'm left with a negative 1 divided by 1 plus x squared. And that right there is your derivative of cotangent. So again, back up here, if I have arc cotangent of x, the derivative of arc cotangent of x is a negative 1 over 1 plus x squared.